But I do think, if we're going to throw a projectile from above the ground, check this out. It becomes important. And I won't be able to use these formulas. So can we? I can't draw.
Is that like something new, or?
Yeah, here's a stick. It's in my aquarium. And that's a snake. Why? Because it's abstract. It's abstract. And it just struck at a mouse. And it hit the mouse, and then it didn't eat it. It didn't catch it. And the mouse just flew in that direction. Initially, at an angle of, I'm making these numbers up, 25 degrees from the horizontal. And initially, the magnitude of the speed was 5 meters per second. Can you tell me if the snake is 1/2 meter above the bottom of the aquarium? Can you tell me how far this thing traveled, the mouse, before it hit the ground? In other words, what's the corresponding range horizontally?
Are we just going to use that same equation and then just add 1/2 meter to it? I mean, assuming, oh, we are using meters, so yeah.
I agree completely. And so everybody, I'm just going to take my vertical component. And my vertical component, if you look carefully over here, is just going to be -1/2 times
That whole thing. -1/2 GT squared.
well, I know it's an application though, so.
G. Oh,
Thank you.
oh, that's what you want.
You guys.
Okay.
T
Squared
plus,
V naught sine.
well, V naught's magnitude, which is 5, times.
Sine of 25 degrees T plus.
I've got an additional component then, don't I? Because I'm not on the ground. I got to add my, what did I say it was?
0.5.
1/2 meter, 0.5. What am I doing?
So-
You're going to solve it.
Solve it when
Oh, when
y is equal to 0. And setting y equal to 0, I guess I get a 0 being equal to -4
something or other.
t squared plus 5 sine of 25 degrees plus 1/2. How would you solve that equation?
Quadratic form.
I would. And I think the quadratic formula tells me this, that t is merely equal to my negative b plus or minus the square root of b squared. Do you guys mind if I'm too lazy to pull out my calculator? Good. Oh, you do mind. Thank you. Did I say it was my b squared is a minus 4ac, so plus 9.8 all over 2a.
You need to sine 20 degree up 4.
Say it again. Did I miss something?
Sine 20
For
degree.
how far is -5 sine?
Okay.
Sorry.
No.
Are you saying I made a mistake?
No, what he's saying is it needs to be -5 sine 25 degrees. In the beginning.
You're right, I did make a mistake, you guys. I didn't see that, I'm sorry. I just wrote down my 5, I meant the whole coefficient of t. My apologies. -5 sine of 25. Is that better?
That's prettier.
And so I think at the end, I'm just going to get 5 sine 25 degrees, plus or minus root stuff.
Well, it's going to have to be the plus part, so.
I agree. All over my neck. And we'll just choose a positive component.
Bam. Whatever that is, that gives you T. And then
You know what, you guys? That doesn't answer the question though, does
So
it?
say you have to plug T into the.
You have to plug it
horizontal
back into
component
the-
now.
We'll make a full sentence. What does this give me?
That gives you the time until it hits the ground.
Gives me how much time it takes for me to hit the ground. To find out the corresponding range for which this
You plug
mouse
it
flew,
into the
you need to go
horizontal.
back to the
Horizontal.
horizontal component. I know I've erased it, but the horizontal component was nothing more than 1.
Something.
The magnitude
V naught.
of b bar, which is, I forget what it is. Is it 5?
Yeah,
Yep.
it's 5.
Times
Cosine of alpha, which is 25. So cosine 25.
Times
T.
5 sine 25.
Beautiful.
plus
That
25.
t value sitting right there.
Just put a line that's hideous. There's no real reason to put all the rest of it out.
I think it's beautiful. I'm gonna write it.
So we just use like an approximate value here,
Yeah, I'm
right?
teasing, I'm just
Okay.
too lazy to pull out my calculator. Which equals some number, which will give you the horizontal range. I just didn't remember as a formula because I think the range is gonna change from the formula the author gave you if this thing wasn't projected from the ground level, that's all.
So how many decimal places would you say we should approximate that to if we're just gonna plug in an approximate?
And just for a
and
test
multiply
question,
it?
I'd probably be really clear with that, I'd probably say approximate your final answer to maybe 2 decimal places.
Okay.
So-
But do you want us to keep it in that form until we reach our final answer?
That gave away my next question. So to approximate this 2 decimal places, you probably get something around.
Well, let me just do that in my head. and-
How about nothing?
Yeah.
You wouldn't have done it. You would have plugged all this in the calculator
Okay.
to maintain the
And
accuracy.
then made a lot of mistakes.
No, you won't make a mistake. Write with a pen. Alleviate the.
I need to get a better calculator. so-
Typically, sometimes I'll make some exceptions. You know, I do have in mind that you guys are taking exams in an hour and 15 minutes. Sometimes I'll say, well, just use a calculator.
So the exam you posted online,
Yes.
was that an hour and 15-minute long exam, or because that looked pretty long?
When I glanced at it, yeah, I thought of that as an hour and 15 minutes.
Ooh, okay.
That's,
Because a lot of those questions were almost immediate.
Huh.
that's not.
No?
Not time for nothing.
Really?
That seemed like a really long test for an hour and 15 minutes. Can we have extra
I
time?
haven't actually looked at it. So.
If
We
everybody
got somebody coming into the room after us, probably.
on Friday? No.
Oh, not on Friday.
Can you, for the,
If everybody's willing to stay.
Can you go over how you would approach that last problem? It was like a little house with some unit vectors, and you had to find where the coordinates of the roof, something like that.
Huh?
You mean a 3 space?
I think it was just 2.
Was it the house problem?
Yeah, it was
Yeah.
two.
I'm sure somebody's got the test actually printed up.
That's what I
And
showed you in the lab today.
Oh, that's not a house. I see. I wasn't thinking house. Oh my goodness, this is trivial. Wasn't it dot product
Doesn't it
between?
give you the dot product between this right here and then that line going from there to there?
Wouldn't the dot product be the product of the magnitudes times the cosine of the angle in between?
And doesn't that give the total vertical height? At least
Oh,
that's
does it?
When I was
What's
looking
it
for
asking?
that's what we got.
It's asking for the dot product between u bar and v bar. Can I just look at the magnitude of u bar, which by the way is times the magnitude of v bar, which can be easily found by the log cosines, times the angle in between, which you can clearly find with the angles I gave you.
So we
It'd be
should
fun.
Memorize law of sines and law of
No, you should know
cosines.
them. We already do. You already took trig.
Well, I took trig like over a year ago.
I know, but you've been using it ever since, and you're the math, haven't you?
Well, we used law of cosines once in Math 30.
Once.
I feel like that's one of those.
But that was a really good application of law of cosines, I recall. Related rates. Guys, can I ask one more question? Yes.
Um,
On the test, so like, because normal class after this, would like go longer or?
I don't know. Does anybody have anything going on afterwards?
No.
No.
Kind of. You have math lab where like you're in the math lab.
Yeah.
Well, that's right, Alex. We brought
I'll
this
just
up
talk to Matt about it. Should be fine.
Yeah, he'll be fine.
So you would,
So we can have extra
Is there a
time?
class behind us?
No, I don't think so.
It's a Friday, dude.
It's Friday.
No class ever.
I see, so we're nobodies.
There's one before us, but not one after.
Yeah.
You actually have it like memorized, or you like whipped out your planner, like, dude,
You're
I
right,
got
we're
this.
in here.
What?
There
No,
are 2 other classes
this is
before
for
us.
something else.
Just kidding.
There's nothing after us on Friday?
Nobody else.
So can we stay late?
I don't mind.
Okay, cool.
You guys, can I bring this into 3 space? I've got 10 minutes. I'll try to do this in 10 minutes. Yes.
is the exam going to 11.8?
I don't know. Brad brought up a really interesting question. He said, I never assign homework in a certain section.
11.6.
Yeah.
Is that true?
Yeah.
Because we already had a quiz on it.
You just suggested last week that we should probably go through it over the weekend.
So I
but,
just said, I must have said in class, just go with the odds.
Well, no, I said, so it would be a good idea to go through 11.8 over the weekend, and you said yes. And that's, yeah.
To read ahead of me, but I'm
Yeah.
talking about the exercise in 11.6.
We never did homework for 11.6. You didn't assign it.
I asked you the day after and you said, oh, well, just do the odds, but it wasn't a big announcement. I just assumed that I just
I did it anyways, but, you know.
No, I can't until we answer this question. Because we did cover 11.6. And I think 11.6 is an excuse on my part, just to retest you on limits, derivatives, integration. Hence that take-home quiz that I just gave you back, which you said I'm late on, right?
Which you were.
I mean, it is really easy, and I mean, if anybody's taken Math 30 and Math 31, they should be able to do it.
Yeah, if you guys don't mind me saying, I did put an exam. I did.
Okay.
And it didn't go beyond that section of
In
11.6.
terms of integration techniques, are we just gonna be sticking to the basic ones that we learned in Math 31, where it was the general case, or are we gonna get?
No, back in 31, you did not learn the basic integration techniques. You became integration experts.
Okay, what I mean is, are we going to stick to the integrals we learned there, or are we gonna be doing like combinations of different integrals, or
Yes.
Partial fractions.
permutations of them? Or are we
Yeah, which you did back in 31. You did combinations of them. Think.
Well, some of us did, I guess. Others, managed to get away with it.
So did I hear that correctly? It's only 11 point, it's only going up to 11.6.
Yeah, because you know what? I remember in class last week, I never finished 11. Sorry, just
11.7 is what we did today.
Yeah, I didn't ever finish 11.7, so that's why I didn't. I'll officially sign it today. But you guys aren't giving me any time to answer my question.
What's your question?
I want to go into 3 space.
Do it.
I just can't hear, I'm sorry. Yeah.
I still don't have my red notebook yet, like my comp book. It has legitimately been 2 weeks since you handed that back, so.
Now, in my defense, I said, I brought it for you, Eric. It's just one quiz. I didn't pass, I didn't grade, because I wanted to upgrade the other quizzes. Get the new ones back.
Okay. And just point that out.
It's okay, you know, point it out. So everybody, I'm gonna throw a projectile in the air at an initial angle. Can I do my initial angle of 25 degrees again? And so everybody, here's my vertical z-axis. And I'm just looking at directions north. Did I get this right? North, east, south?
No. Oh, never mind. Facing us, yes.
And if I treat this as the x-axis, this is the y-axis. Then let's suppose I throw a projectile upward at, how about a velocity of 100 meters per second? Initially, that's going to be its magnitude. And I've got some kind of wind blowing, say from east to north, east to west. And it's blowing from east to west, let's say, with an acceleration of 10 meters per second squared.
What if it's at an angle?
What was that?
What if it's at an angle? It's not going, it's not blowing straight on that.
Complicates things too difficult. And if I had an angle, you know, I'd probably cheat. I'd rotate my coordinate system. No, seriously, just make it easy. I really would. And let's see if you and I can't find how far this object travels before it hits the ground. It's being fired from ground level. We got 5 minutes. We can do this. Because I think in 3 space, initially, I think the acceleration as a vector is simply going to have these 3 components. I think I made a mistake. I'm wrong. Because when it comes to the wind, if it really does have an initial acceleration, which by the way is probably too big, but let's just call it 10, then I think that's going to be in the y direction, at least the way I drew my picture. Do you guys agree?
Positive.
Yeah. Well, I think it's positive because it's traveling from east to west, and if I call this the y-axis, I guess it's going in a positive direction. I could easily have done the other direction. And therefore, I think my corresponding velocity vector, in terms of t, is simply going to be, anybody?
Your responding velocity vector is just going to be nothing, 10t,
I can't
negative
hear
gt.
you.
It would be a constant.
Yeah, c, is that, it's just going to be recent.
If you
100
integrated,
meters per second.
yeah, you'd have
100 what?
100 meters per second.
100
Cosine theta.
cosine of
25 meters.
25 degrees, because that's my initial velocity in that direction.
Okay, but, your initial velocity in the x direction is that, okay. I get you. And then 10t, and then negative gt.
Well, 10t plus 1.
plus c.
Plus one.
Sine.
100.
Plus 0. Because if I throw this projectile directly north, I think there's no y component.
Okay.
I do think, however, for the velocity function, my variable component is going to be, is that a negative 9.8 theta
No, just one.
well, I think something, plus 100 sine of 25 degrees. After all, when it comes to that initial velocity, it's got a vertical z component, doesn't it?
True.
Now, to finally come up with my position vector, I think my position vector r bar t is merely going to be what I get when I anti-differentiate, but the constant vector that I generate by constant integration has components.
X, Y, and Z.
Has components. Look at my picture.
0, 0.
0, 0, 0, because I threw the projectile away from the origin initially, or your r's. Now, my r's not, in other words, is a 0 vector.
Yes.
And I think that gives me 100 cosine of 25 degrees, by the way, as a constant, times t plus 0. Comma, is it a 5t squared plus 0 again? And finally, I've got my negative 4.9t squared plus as a constant, 100 sine of 25 degrees times t plus, I agree, whoops. I forgot my question, I said it too fast, darn it, what was the question?
How far have you traveled in the X?
Yeah, what is the range of this
So,
projectile?
isn't all you're gonna do, oh no, why did you do that?
I heard that.
Yeah.
First find out when y is equal to, or actually, you meant when
Z
z
is
component is equal to
Z
0.
is equal to 0.
So my z component as a function t is going to be equal to 0 when my negative 4.9t squared.
It's just 4.9
100.
divided by 100 sine 25.
Yeah, I agree. I guess I'm wasting too much time writing it.
Yeah, you have like 1 minute left.
Okay, all right, fast. So t is equal to 100 sine of 25 degrees.
Otherwise,
Say again, when we set the z component to 0, what exactly are we finding?
Zero.
To ground?
Well, let me go back to Linda to the original question. How far does the thing travel for histogram? I'm really looking for the x component.
Okay.
I just can't use the x component unless I know what t is. So to find out how long this thing is in the air,
Yeah, to find out how far it travels.
I will first,
Along the x-axis?
yes, I
Don't you
projected,
have this other-
well, I took that into consideration for acceleration. But the bottom line question is, what is a horizontal component for the resulting position function? And so I just maintain I should first find out how long it takes for me to hit the ground. I should find out how long it takes for the z component to be equal to 0. Once I find the value for t, I'll simply plug it in right here for the x component. And I think t is equal to 0. Eric, did I do something wrong?
no, I thought for a second you did, but you did.
And now I'm going to take that x component and divide it on this particular value of t. And I think finally, if you guys will allow me to get away with not using my calculator, I think finally that gives me that the x component is 100 times 25 degrees times my numerator, all over 4.9. In measured in meters, of course. Yes, sir.
Just really quickly, we're trying to find the distance of travel from its initial position, right?
Horizontally, yes.
Okay.
You guys, do you think I